Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 244. Minimum space wasted from packaging. So hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this farm. So this is going to be a little bit weird because I'm re-recording it, but because I have a second explanation, the one that I like better. I did this during the contest, so just to give you a little bit of background, I did this during the contest in a very funky way with a prefix sum. You can actually watch me solve that live next, including the video that I originally recorded for that one. So in the beginning, you get to understand my explanation of that solution, which is very long and not. I mean, it's I got it accepted during the contest, but it was very error prone and there was there's a lot of math involved. But it turns out that the math here is actually a lot easier. And this is and I like the solution so much that I recorded a second video for it and had to delete it and everything and redo it again. So let's jump to it. So the idea here is that you look at here you look at this thing and let's pick a bigger thingy, okay? Yeah, and that's for the purpose of this problem. Let's keep it this way for now. But let's say you have 12, right? What does this mean? Well, 12, you have 12 minus 12, 12 minus 11, 12 minus 10, ... right? So that's obviously the you get some number here, right? Actually, let's actually write that out. So you sum all these, but let's just write that out for now, right? But as you can kind of see, the key part about this, because the idea that I had originally was using prefix sum, and it worked because like I said, I got accepted, but it took a long time, and I was just in debugging indexes and stuff like that. But this one is much easier, which is why I had to do a second video. But the idea is that, okay, this is the formula. Now let's separate them out, right? Okay, so in this case, it's all the same number, but that's less interesting. So I think I skipped ahead a little bit because, like I said, I do actually explain the basics of this in the second part, which which I will afterwards, but I think because I'm explaining it again, it's a little bit awkward. My apologies. I still hope you still do it. But yeah, the idea is basically sorting this first and also sorting each of the supplier. The key thing to notice here is that the sum of all the boxes and all the suppliers are 10 to the 5th. And because they're only 10 to the 5th packages as well in N, you can do for each box, if you do a binary search, a logarithmic search, that'll be fast enough. So okay, so having that base foundation realized, you have this formula. It's hard to kind of tell a little bit from here, but per se in this way. But you can kind of see the basics here, and let me sort this for now. But the key idea is that, okay, well, if you take out all the negatives and you take out all the contributions, well, it's just 12 plus 12 plus 12 plus ... plus 12, and I think there's 6 of these, so which is just 12 times 6 minus, well, what is this minus? Well, it's minus 12 plus 11 plus 10 plus 8 plus right? Or, well, I guess it's just 2 more. I don't know why . And this, of course, these are just the numbers in the original array, right? Let's make this bigger. And that's the key thing to notice. And okay, let's try the second supplier. Okay, so and this is this part should be intuitive, especially if you're solving hard problems. It's going to come in handy, or it's going to come in a lot. Is that obviously you want to binary search the 9, you want to do the 5, 3, and 8 to contribution. So let's just write it out real quick. 9 minus 5, 9 minus, oh, I skipped a number. 9 minus 5, 9 minus 3, so those are the contributions. You add them, of course. And then for the next number, 11, okay. I'm just going to cheat a little bit and add a bigger number. But yeah, and then now you have 11 is 11 minus 10, or 11 minus 11, 11 minus 10, and then 15 minus 12, right? So you do a similar thing. It's 4, let's start 5, 5 minus 5, 5 minus 3. You have 10 minus 10, 10 minus 8, and then you have 14 minus 12, 14 minus 11. So yeah, and of course you sum all these up. But notice that in every part of this, and maybe I could resort it this, you know, if you resort this in a way, notice that every package number is used on the right side one. So in here, again, we're going to have this thing, right? So this is some, you know, this is 9 times 3, plus 11 times 2, plus 15 times 1, minus this thing. This one, you have 14 minus 2, plus 10 minus 2, plus 5 times 2, minus, you know, this big thing, right? So now, hopefully, you see the pattern. And the pattern is, you know, the sum of the things are on the right, but here is basically, well, how many packages are using these boxes, right? For example, 14, and in this case, it is just becomes a sort of moving the pointers, and it's kind of like a sliding, maybe not sliding windows, but I keep saying that for everything. But it's basically like a sweep line thing where you go, okay, you sweep, and then you do a binary search for the next point, you sweep, and so forth, right? So, okay, so what is this in concept? So what this means that for 5, okay, well, we binary search for 5, okay, we see that we have 2 packages, okay, they're done. Okay, and then now the next box is 10, so then now we binary search for 10, okay, so now we have 4 boxes, but previously we used 2 of these, so now we only use 2 boxes for 10. And then lastly, you have 14, which uses 6 boxes if you do a binary search. But of course, we already used 4. So yeah. So then, you know, yeah. So now you only use 2 boxes, as we said. And that's pretty much it. So there's a lot of math and intuitions. And once you get that, you know, the implementation, it should be a little bit easier. This is code I've written afterwards, and now that I think about it a little bit more, I didn't even need this. I just yeah, I mean, it's fine. But yeah, so let's go through it. As we said, we sort the packages. The number of packages are, or we have a total, which is, as we said, oh, I deleted it, but that's just the sum of all the packages, as you have shown before. And then for each supplier, well, we sort the boxes given by the supplier. This is basically, if the biggest box is smaller than the biggest package, then it's impossible, so we skip it. Otherwise, we just sum up all these things, where, okay. As we said, we do a binary search. We do a bisect right -1 to, you know, get the smallest number, the smallest box that fits in this box. You could kind of reason that out a little bit, but yeah, if the last index is not none, so if the last index is none, then this is the number of boxes you need, and this is the size of the box that you're given, as we said before. I really shouldn't have. Okay, yeah. So basically, for example, in this case, this is just the number of boxes you need. So if you have 5 and you binary search for 5, this is index 1, so you have 2 boxes. That's basically the idea. And then you set the index as you go to the current index. And then the next time around, you just get the delta number of boxes, and then you get the boxes. So this basically gets this part, and then the total is this part. And at the very end, okay, if it's still infinity, that means that, you know, we skipped it every time, so we return -1. Otherwise, we subtract the total and we get the answer. This is the answer that I recommend. I did not do this during the contest, just to you know, give you a little bit of, you know, like this requires this kind of reduction, which is kind of hard for me anyway, because I'm not really good at the algebraic manipulation. That's always been my weak point. But that said, I want to also give you, what you see next. It's going to be me explaining the way that I did it during the contest, which is fine. But it also shows that there are different ways to solve this. And yeah, okay, I solved it in 35 minutes instead of 15 minutes because of a debug and whatever. But it also shows that, if you hustle, if you keep on going, if you keep on grinding, you could get an answer. It might not be the best answer, might not be the perfect answer, but it is actually also optimal. Maybe not space-wise, but it's actually, I think it's optimal, roughly speaking. But, it's still a pretty good answer, and it's time optimal, and, so you don't have to... So yeah, so it's still an answer. I still got, a good rank, decent rank as a result. So that's what I want to encourage as well, is that, there are more than one ways to do it sometimes. And as long as you keep grinding, you can get there. Yeah, let's go over the complexity real quick. So the number of total boxes, let's call it K, which is this sum, it's going to be 10 to the 5th. And for each of those, we do a binary search. So it's going to be K times log n, because there's going to be each binary search costs log n time, because that's the number of n in package. Yeah, so that's pretty much it. K log n is the time complexity. For space complexity, you could do a lot of math around it, because technically we don't use that much extra space because we sort the original input. But as you know, and as I always talk about, you probably should not sort the original input, because if I pass in an input in any random way and I come back and it's all different, I'm not going to be happy about it. So technically you should use the linear extra space and make copies and then sort and so forth. But otherwise, technically speaking, linear space, K log n time. That's all I have for this one. So what you're going to see next is a little bit awkward because I didn't edit it. But you're going to see me do the intro. But I'm going to do an explanation of... it's me doing an explanation of my solution during the contest. It has the same idea, but I did it in a different way. And it basically, the only thing that I missed is skipping this reduction, and this reduction is a beautiful reduction as a math nerd. So, and it makes the code much easier because I didn't have that. I did it with a prefix sum and a lot of arithmetic, a lot of places to get wrong. You can watch me, like I said, you can watch me doing it. Cool. That's all I have. Watch me solve it another way, and hope you watch the video afterwards. But you should watch it on 2x or something. It's a little bit of a mess. But yeah, I'll see you in a bit. Hey everybody, this is Larry. This is me going over Q4 of the weekly contest 244, and as you saw, I took 35 minutes. To be honest, I did this. I got most of the code really quickly, but I just got some typos and maths and stuff like that. But yeah, and this problem is minimum space wasted from packaging. So yeah, and you could get to watch me solve it live during the contest and struggle during the debugging very painfully. So maybe on 2x or something. But yeah, so hit the like button, hit the subscribe button, join me on Discord, give me some love and support, and yeah. So the key thing to note in this one is actually that the sum of all the boxes is 10 to the 5th, meaning that, okay, so also the number of packages is 10 to the 5th, but that means that, this means to me that, you cannot go for every supplier because there could be many suppliers. And if you go for every supplier and do something funky, it may be too slow. But because the number of boxes are 10 to the 5th, meaning that if you're able to binary search on packages, 10 to the 5th number of binary search is going to be 10 fast enough. So that's basically the thing that I noticed and do the premise on. And this problem, I'm not going to go over the math like too much. There are a lot of ideas here, and I struggled with them during the contest, so maybe I'm not even that good in explaining it. But I just want to go over the concept of how I solve this problem. The idea is, okay, first of all, I don't know if package is sorted, but I sort it anyway because you never know if if you sort it, it makes it easy to not have to worry about it. But yeah, once you sort it, then the idea is that okay, well you sort all these packages and then you sort all the boxes or all the boxes within the supplier, and then and then you do essentially a 2 pointers algorithm in that you move pointers to the left and then you move it to the right. In theory, you do it one at a time, but as we talked about, that could go really slowly if depending on how you implement it. But the thing is that this is in an increasing order because well you sorted it, so you're able to do a binary search so that you could jump ahead, right? That's basically the idea. The maths are a little bit tricky to get right. I did the prefix sum here to try to do the math correctly. And this is kind of the math. I want to say it's a little bit annoying to go over, but I just want to make sure the visualization is good. So I'm going to pull up Paintbrush real quick. Let's pull that out. Hang on. So yeah, so basically the idea is that okay, you basically have all these numbers in a number line, and this is packages, and then you have 2 pointers, right? You have a pointer that goes on the packages side. I'm just going to put P, and then one in the supplier side. My computer is crap. On the supplier side, and then the idea is that if you pre-process it enough, then you can move the supplier by binary search one at a time, or yeah, you can look at for each boxes on the supplier, you can move them, so that it goes all the way to the end, and because there are 10 to the 5th of these, that's just 10 to the 5th binary search, and because this line is also 10 to the 5th number of packages, that's just log of 10 to the 5th. So that's basically the logic here, and you kind of move these pointers as you go. The idea about the tricky one about this, oops, that's not the right thing. Let me remove this. So I did it this way. I think they're probably actually easier maths to be done, because the way I did it is a mess, to be honest. But hopefully, now that you have the idea, maybe you could pre-process things in a different way. But the way that I did it is that, okay, I calculate the prefix sum and the prefix count, which is just the index. So this was actually not that necessary, but I wasn't thinking that straight. But basically, this is the idea is that, let's say, I have this as the input, right? And now we're just going to reduce it to one supplier because it doesn't really matter, because you're just looping through them and then taking the max or the min in this case. But yeah, but in this, let's take another number in between, maybe a 2. Let's say they're both sorted. So now 5, we binary search to get this 5. We get the prefix sum of all these numbers, and this is a special prefix sum in that it multiplies by the number of count, so that here at 5 we know. So then you can do kind of a reverse prefix sum, because 5 you want to pre-calculate the answer of 5 minus 5, 5 minus 3, and 5 minus 2. So you added all these, right? And of course this is just Leetcode 2. If you do it in a prefix some kind of way, 3 minus 3, 3 minus 2. So this is just, if you kind of scale that out, this is just 5 minus 3 times the number of numbers you've seen. So that's basically what I have here, plus the current number, or the last number, that is. So that's basically the idea here. And as we said, first we set the answers to some infinity. I just chose a random number that's big, so that it doesn't have a collusion, just in case. Because at the end, if we didn't change it, then we return -1. Otherwise, we return the answer, the mod that they want, right? And yeah, so then the waste is, okay, so we saw the supplier box. So this is not possible if the bigger box available is smaller than the biggest package, then it just won't fit, right? Because, you know, so then I just skip this. Otherwise, we set the waste is equal to 0. We set the last index, and this is the key part that I had a lot of time. I spent a lot of time getting this part right, but the key thing is noting that, again, if we had the thing that we had before, like let's say you have 1, 3, 5, 6, 9, say, and you have 5 and a 10. So basically the idea is that, you know, if you have a 10, okay, you take the prefix sum here, but you also want to remove all the prefix sum here, right? That because you already, you know, those packages already have a box that correlates to them. So basically you know, so that's basically the idea, and there's a lot of math as a result. I literally spent about 15 minutes coding 95% of this, and I spent 25 minutes debugging this. So that's how much of a struggle it was for me. But yeah, so I do a binary search here. I just wanted to make sure that, you know, if this is 0 or if this is -1, that means that the box is too much for the no packages needs to be in this box, so you move on. I printed 1, though I guess that technically I should not print this. That might actually lead to some weird stuff. But this shouldn't happen that much. And then after that, we have to this is just a lot of math. If there was a last index, meaning this is in the first box, if this is the first package to be picked up, then this is easy math. It's just the prefix and then also the delta. So the delta is just the difference in the difference in size between the largest package, because the prefix sum gets us to the package, the size of the package. So then the delta will get us to the box, because then we just times it by the number of boxes, and then we add it by the prefix sum, as we know. And if last index is not none and it's equal to, this is equal to the last index, that means that no new boxes has you know, no new packages picked up. Otherwise we do this whole mess. You can kind of, I'm not going to show you why this is the case, because it is the intuition I always showed you. To be honest, like I said, I spent 25 minutes literally on this one line of code. So if I did that, you could try to figure, and like I said, like it's just about being really careful, which I was not. I was very sloppy, and that's why it took so long, because I was just trying a lot of different things instead of really stepping back and thinking about the principles. And you could kind of derive this formula, and you could kind of do a piecemeal, because this part you have already seen. This is just, you know, the number of new boxes that we're processing, which is this part. This is the number of new boxes that we're processing, and that's the delta in size. This is the prefix delta, because that's just the number of deltas, and then times the number of smaller boxes that we double counted, which is this portion. I know that this is hand wavy a little bit, as I said, you know, try your math. Maybe there's an easier way to do it in other solutions, but that's the way that I did it. We'll make them a little bit smaller so you can see them all. And then at the end, you know, you have the sum of all the waste, and then you take the minimum number of that, and that's pretty much it. So in concept, to be honest, like I said, I was able to do this in probably in concept 10 to 15 minutes. People, the really good people did it even faster. So in theory, if I did it correctly the first time, I actually even would have finished in the top 25, maybe 30, maybe 50. But that debugging really killed me, and I have a wrong answer because I think I forgot this part, which I was thinking about. But when you spend 25 minutes debugging, you just forget everything. You forget what your last name is, as the saying goes. But yeah, that's all I have for this problem. Hopefully this is good enough for you to at least attack the problem in your own way. And yeah, you could watch me solve it live next. Okay, cool. Q4. Minimum space wasted from packaging. 4 people already done, so that's gonna be tough. Okay, yeah, one package in each box. There's too much reading on this one. I don't have the attention span. I've been drinking all day. Okay, one package. You have n packages. You try and put them in boxes. One package in each box. The m supplies that each produce 5 different prices. So there are infinite amount of these. A package can be is less than or equal to the size of the box. What does that mean? Okay, so each supplier. Okay, so these are the packages. We know that. Okay, so we can go with 1 or 2. Okay, you want to see total wasted minimum space? Okay, the sum of space wasted in 2 boxes. Okay. Okay. First of all, mod. It's not really a good song, but I still sing it anyway, because otherwise I forget. Is that right? Yeah. Okay. And I've written this before and still forgotten it, so I have to change the return statement. That's why I do it this way. But okay. Okay. What are the constraints? The constraints are all 10 to the 5th-ish. Some of the boxes of length. Okay, so yeah, that's fair. Okay, so what does that mean? That means for each. Can we just binary search? Is that too much work? I don't get it. So because we have to do it for each m, and each n we have to do a search for each m. That may be too much. So you can't just do binary. Oh, at least not naively. Because here, for example, we just go through all the boxes. Okay. That's an interesting problem then. Because if you have one supplier, then you could do a binary search. Are the packages unique in any way? No, just boxes. Okay. That's sorted. Sometimes sorting helps. So okay. So we sort everything. We can just do. No, because for each n, it's still going to take m things. So that's going to take too long. And for each m, no, but the sum of all the boxes 10 to the 5th. So we for each one. Okay, let's say we have the 5. Then here there's 2 spaces. And then 10, and then 14. How do we do it in an efficient way? And for all the boxes, if we're able to, okay, for each of these boxes we do a binary search, but it doesn't tell us enough about the space. So we want to do a prefix sum and then binary search so that we can do the spacing efficiently. I think that's right. I refresh sometimes to see how many people are updated so that I could kind of gauge a little bit on the difficulty. But I think prefix sum makes sense. Yeah, okay. So there's a lot of bookkeeping in it though. Yeah, okay. Okay, so for supplier and boxes, so we just want to sort this too. Okay, so we want to do prefix sum. Okay, let's do that. It's not a prefix sum, but it's like a prefix delta. So you have to do a lot of math with it. Okay, so for package in packages, so counts pen, just increment the count, and then we take the delta in this package and the last package, I'm getting too fancy. So then packages index minus package index -1, and for the first box the prefix is 0 and the count is 1. Maybe that's okay. Yeah, let's just do index 0, 0. We continue. So then now prefix pen, the last prefix -1 plus this delta, and then now let's just print it out real quick. I think I'm on the right track. It's just a lot of bookkeeping and trying to make sure that it is right. Yeah. Yep. Okay. 013. Is that what I want? Yep. This has a total sum of 1 with 2 numbers. This has total sum of 3 with 3 numbers. Okay. I think I'm on the right track. Okay. Okay. That looks Gucci. And then now for each supplier, we do the math, right? Wastage 0, 0. Okay, so okay, and this is equal to -1, and we have to remember not to mod this, I think, because otherwise you may mess that up. Yeah, okay. Wait, what? Minimum, so I guess that makes sense. Okay. Minimum is weird because you have to do a minimum after the mod or something, but I guess that's fine. So if answer is equal to -1, return -1, otherwise return the mod. Okay. If supplier of -1 is greater than packages of -1, or the other way around, if the biggest package is greater than the biggest supplier of boxes, then we just move on. Otherwise, we do a sort of binary search. Yeah. Yeah, okay. Yeah, okay, we do a bisect left of packages, get index Okay. Well, this is for each box that we have. For box in supplier, we want to search that box in the thing. Is it bisect left? Basically, okay. It's a bisect right and then -1, I think. Because basically you have a box, it fits everything that's smaller than it, so we want to get the, yeah, and then it's this -1. If index is 0, I mean it has to be within packages because of that, but let's just add it in, it's fine. So now it's okay, so the delta is equal to box minus prefix of index, and so that's the sum at that point. No, that's the now this is packages of index, so that's the delta, and then race is just equal to, or add the delta times counts of index so the wastage is this. No, is that right? Did I mess that up? Delta times counts. Yeah, so okay, this part is right. Plus prefix of index. No, that's not. Is that right? No, that's right. That's because that's the prefix before this last box. And that is, yeah, okay. But then this doubles count. So we have to do something like last index is equal to index. Maybe. If last index is not none, then we have to subtract the difference, which is just so the reason why you don't, or you subtract, or you want to subtract this, is because now this prefix counts too many things. So maybe something like that. I don't even know if this is right, to be honest. Yeah. Okay, well, that doesn't sound good, but how does that happen? Race should at least be 0. Oh, because answer is okay, fine. Okay, 12 something and 9. Okay, I mean partially right, but I think I just have my math wrong. But okay, and the second one's right, but that's very trivial. Okay, so how did I get 12, 4 and 8? So we have 14 and 12, both of which are very wrong. How did I get 12? This is a little bit awkward. I need to figure out, this is definitely wrong, but I'm trying to figure out what am I trying to think of. This is where pen and paper would be helpful. But okay, so this is the delta up to the box, and then you get all the prefix of that one, sure. But then you also want to subtract we definitely want to subtract this, but we might not. Okay, so we definitely subtract this. But so the answer, okay. I'm talking a lot more than I usually do, but that's fine. So I have 4 and an 8. So 4 took care of these two. So then it's only up to the 5. So then the prefix sum would be this minus the prefix of 3. No. It should be the prefix of all the stuff before 5. Okay. Is that the only thing that matters? Or is that correct? Okay, it's still wrong though. So for the 4, like I feel like I'm close, but not quite. Okay, so then 4 you have 3, which is right, and then 12, which is wrong. So that should be 3. None, so prefix is 1, so this would return probably just 1, right? What was the last index? Last index was 1, so prefix of 2 is 3. So we want the answer to be 3. Why is this prefix? This is 3. I guess that's right. So minus 3, but how did it get 12? Because it takes... Oh, I see. Because I did the delta math wrong. Okay. This should be this minus counts of last index. Okay, now we're kind of in business. Let's kind of check. Let's check the math, right? Okay, 4, 8 is 6. Is that true? I guess that's true because that's given to us. Is the 8 correct? So 2 matches to 2, and then 8 matches to 5, which is 3, and then 5, so that's 8. Okay. This is here 12. This is 9. Is that right? That seems a little bit low. So I don't think this is right. Because for 12, oh, do I set? No, I set it here. Okay. 9 feels too low. So that's 1 plus 2. So that's 3 plus 4. That's 7. 7 plus 7 is 14 plus 9 is 23. So that's just totally wrong. Why is that so wrong? Because I don't know that I do that right. What? No, I don't. So it's not here. So yeah, so even in the right answers, you can modify. Like I got the right answer, and I could have submitted, but it doesn't make sense, right? So yeah, so 5. So the delta is 0. Oh, so this thing doesn't happen. Oh well, it's here anyway. And then it's prefix of index. Did I get this wrong? What is the prefix? Maybe I did get it wrong. Because this should be... Okay, so this should be factor in the counts as well. So I didn't do that. So it should be this times counts of -1, maybe. Okay. What is the right answer? 9? That is this or this, because that sounds a little bit high. Okay, so that's also wrong. How do I get 9? So for the 10, 14, 20, we get 22. Why? Because 14, you get these 2, which is 3. So so the 5 gets 4. Is that already wrong? I think that's already wrong, to be honest. Should be 2. Right, the prefix is 0 and 4, so the prefix is wrong. Here should be another, so it should be 2. Okay, maybe this is right. Yeah. So 5, it should be 2. That's good. The 10 gives us an 8, which is a little bit high, I think, because that's just 2, and then that's it. So this should be 2, but it's giving me 8. This is gonna be... I mean, I feel like I'm mostly right, but I'm getting a little bit wrong on the details. And my next door neighbor is playing some loud music. Maybe not loud enough for you to hear, but it is annoying to me. Okay. I mean, it's definitely here, so let's print it out here. Why not? So we do subtract 8. So delta is delta should be 0. Yeah, the delta here is 0, and okay, so this is 14 for the prefix. I have to figure out how to do this prefix correctly. So okay, so the prefix takes account the count. So we want to minus this prefix, but we also want to minus so it's something like this. So this is the delta, and then times someone like that. I don't know if this is right. Now I'm just like really confused, and seemingly wrong, because now I have 14 instead. How many? What is this count? So delta is 0 in this case, which is what we expect. But this thing returns 14 because prefix index is 14. Okay. So we have two numbers, which is true. So it's just 10 and then two numbers, right? So then this minus this so it should be this minus what is this wrong? This is the worst. Debugging is the worst. So this contribution is 12. Y. This is 14. This is 8. Oh, this is wrong, but we want to subtract. Oh my, math is hard. So the prefix is so the prefix sum up to here is 12, up to here is 8. Okay, and we want 12 minus 8. Is that good enough? Nope, because that gives us 4. Why is 4 not good enough? Because it increments, because we count. So the answer should be, is this 12? No, it's 14. I said 4, but so this is 14 here, this is 2 here. So then this gives us 12 for these two, but it includes these two numbers. So we want to not include we don't want to include the prefix of 8 actually. So this is going to be 8. So it should be 12 minus 8, and then that's 4. But 4 is still too much. Why is 4 too much? Because these two delta, we want to subtract that, and we want to subtract this stuff. This now looks really awkward, but okay. Now we have some ridiculous numbers. Man, I've been debugging this for like 15 minutes. This is really bad. And I know all the math. I'm just really bad at it today. Okay, so it's 14 and 8. What does that mean? That means that there's 3 numbers that are counted here that are not counted here. So we want to not count this into the delta. And okay, and that's clearly really wrong because now we have negative numbers. So we have 12 and 8, and then we want to minus another 2. Because we have 14 and 8, so we have 6 in between, but 6 includes so we have 6, but 6 includes 2 previous numbers. So yeah. Now, so I want this to be not that. This is just packages. Okay. Let's hope that that's right. But okay. So then now, this is 4. So we have 2, we have 4, and we have 9. Okay, let's do it manually. Take your time, Larry. Slow it down. Okay, so 12, we have 23. That's probably right. Okay, now we have 9. Where's the 11, 9? Oh, because 11 is too small. Okay, so 5, we have 2. 10, we have 2. And then 14, we have 2 plus 3. So that's 5, so that's 9. Okay. I think the beauty about this one is that you can generate more test cases and work them out by hand. I don't know if I should YOLO on this one, but let's do it. Let's one more test at least, and also we need to remove some print statements. Yeah, okay. This is still gonna be 9, but let's see. So so this gives us 15. Let's check that math. So 15 will give us 3 plus just 3. So 3 plus 0 plus 1, so that's 4. This is 1, so that's 5. 5 plus 4 is 13, and then 6. Wait, what? Okay, let's do it back. 9 is, so that's 1 plus 4 plus 6. So that's 11 already. 11 gives 0 and 1, so that's 12. And okay, so that's right, or at least it checks up for this one. Do I have anything? Oh, this infinity may be too small actually. So, or like, you know, it might be I don't know. It might still be too small, but let's just make it like some random number so that it doesn't happen by chance. I think that's more worrisome than being too small, but let's give it a submit. Oh no! That was a very quick one-time error too. What happened here? 7866. Line 28. So 6 and 8. Oh, I did think about this case, but I forgot about it, I guess. So basically what happens is that last index is the same as this index, so then this thing doesn't happen. So yeah. So if last index is equal to index, continue for the next box, I suppose. Okay, let's cross our fingers. Hopefully this is right. If not, I'm just having a lot of wrong answers, but okay. I mean, I mostly got that one right. It's just I had a lot. Yeah, I hope you enjoyed chilling and going through this problem with me. Stay good, stay healthy. to good mental health. I'll see y'all later, and yeah.